Is it almost like a nuclear reactor where you have water that's cycling through cold water to cool the system?
The difference is that a nuclear reactor is designed to generate heat. So you want the water to get heat, and then you use the heat to generate vapor, steam, and then with the steam you run the turbine to generate power. And the cooling of servers is transitioning from air-cooled to different form of liquid. It's a big transition. From the technological and infrastructure point of view, is a big change. If you have 100 megawatt, which is the equivalent of 40,000 homes in one building, you have to remove a lot of power. And traditionally, computers and servers for data centers are air-cooled. The computer that is sitting on your desk probably right now, or your laptop, the fan going when it gets hot, that it's cooling the processor. Air is no longer efficient, is not an efficient way of cooling stuff. And so I joined BP relatively recently. I have kids, and I would like to leave them a word that is better than the one that I actually inherited.
Today on the show, I'm happy to have Cosimo Pecchioli. He's the OEM Partnership Director for British Petroleum, BP. So today we're going to dig into data centers and actually particularly how to cool them with some of the latest tech. So tell us what's happening, what's on the cutting edge right now?
I'm sure you heard about artificial intelligence, but this is just the latest chapter of an evolution that has been happening for quite some times now. And the computers are getting more and more powerful, and that means they're getting more and denser, which means that you're packing more power actually in the same space. And something that not everybody is aware of is that computers are like perfect eaters, means that almost 100% of the power that a computer uses turns into heat. For the law of thermodynamics, there's nothing else they can do, they don't move. So if you have a 100 watt computer, you have 100 watt heat that you need to remove from the room. And if you have 100 megawatt, which is the equivalent of 40,000 homes in one building, you have to remove a lot of power. And traditionally, computers and servers for data centers are air-cooled, like the computer that is sitting on your desk probably right now, or your laptop. You hear that the fan going when it gets hot, that it's cooling the processor. So traditionally are air-cooled, but as the density goes up, air is no longer efficient, is not an efficient way of cooling stuff. A fan for you is actually much less pleasant than jump into a pool, to make a real life example. And so the cooling of servers is transitioning from air-cooled to different form of liquid cooling. And this is what is happening right now. And it's a big transition. From the technological and infrastructure point of view, is a big change.
Is it almost like a nuclear reactor where you have water that's cycling through cold water to cool the system?
In a way, yes. The difference is that a nuclear reactor is designed to generate heat. So you actually want the water to get heat, and then you use the heat to generate vapor, steam, and then with the steam you run the turbine to generate power. So in a nuclear reactor, actually, heat is the primary product. In a computer, heat is a subproduct. It's something that you don't want, and so you need to remove it. And amazingly enough, the amount of energy that you use to remove the heat that you produce in the first place can be significant, can be 50, 60, 80% of the total energy that you use. So if you use one to feed the computer, then you need to use almost another one to cool down the computer that you fed in the first place. So you understand how any improvement in the efficiency of cooling actually is a significant improvement in the sustainability of the industry, because you use less energy to have the same product. And so as you improve the efficiency of cooling, you use less and less power to cool down the computers, and then you use in general less power.
What are some of the challenges of implementing a new piece of technology like this into data centers?
It's multifaceted. I would say the biggest one is just human nature. Changes is always difficult. And so you have a generation of technicians and engineers and designers that grew up with air cooled solutions, and now they have to acquire new knowledge and experience. And that it's always challenging per se. And then you have actually more technical challenges because you have a whole infrastructure, the whole buildings of the whole cooling system that is designed for one medium, which is air, and then needs to be adapted to a new medium, which is liquid. So to give you an example, in a current large air cooled data center, and if you're not familiar with the data center, it's a very anonymous building. Normally it's a 1-story, 2-story industrial building with nothing that you can actually see from the outside other than a large fence. Security, it's very important in data centers. So normally they pay a lot of attention about who gets into the data centers, of course. But if you don't know what to look for, it's hard to actually spot a data center from an Amazon warehouse. They look almost the same. There are things that you can notice, but so that building, for instance, might not even have pipes for water inside of the building because it's completely air cooled. When you actually start to bring any kind of liquid cooling solutions, you need to run water through the whole building. And now it's not a mundane change because we are talking about very large 12, 24, 36 inches pipe. I mean, these are very large pipe because you need to move a lot of heat and a lot of water, therefore. And so these are to upgrade a current hyperscale, which is the biggest scale of data centers that we have currently, to update that from air, so waterless, completely without even pipes, to liquid cooling. We are talking about hundreds of millions of dollars, and then a lot of time to design it properly. There's a few things. You have very valuable equipment inside. You have even more valuable information inside of that building. And disruption is just not an option. A data center needs to be up 99.98% of the time at minimum. And so any kind of problem, if you have a gasket that leaks, if you have a tremor, if you are in a seismic area and you have thousands of joints with all these pipes, they cannot leak ever. For instance, you have maintenance, you have human errors, and you have to factor all these in and idiot-proof everything and nature-proof everything to make sure that nothing happens. So you can see it's not just running irrigation pipe in your backyard; it's a major endeavor.
Is this something that new data centers are going to have implemented into them, these liquid cooling? Or are we moving to a transition of air to liquid?
I would say new data centers now are designed to be more future-proof. And
A quick note from our sponsors. I want to thank SkuTrue for sponsoring the FTS podcast. It's a great tool for e-commerce sellers. I've had an e-commerce business for over a decade now, and I just needed something out of the box to get the job done quickly. And what I found with SkuTrue is that it takes my products on Amazon and very quickly and seamlessly moves them to my markets on eBay and Walmart. This is a solution I wish I had sooner. Back to our episode with BP.
I would say new data centers now are designed to be more future-proof. And so even though maybe currently they are still 95% air cooled, they have provisions in their design in order to be more flexible. And it's going to be easier to change the building as the technology changes. Of course, no one can know what's going to happen in 15 years. You cannot future-proof the unforeseeable. Otherwise, definitely no one designs a data center now without any provision for future flexibility. The challenge is that data centers, you have plenty of new buildings, but you have even more existing legacy buildings. And consider that large IT companies like the Google, the Meta, the Amazon Web Services, the Microsoft of the world, to name a few of them, but most all of them, particularly in the US and Western Europe, they have very high sustainability goals that they want to achieve in 2030, 2040, 2050. So relatively soon, 2030s, 6 years. It's a very short period of time, this kind of business. So it's not that you can completely flat out an existing building and build a new one that has a huge CO2 impact. So these are the kind of considerations that they actually do all the time. And so they're really trying to be sustainable all around.
I want to talk a little bit about the Open Compute Project Foundation. I know that's something you're involved in.
Yes. So the OCP, as is known, or Open Compute Project Foundation, is an organization that was launched in 2011 by Facebook at the time, now Meta. But now if you go to the website, it's easier to list the companies that are not part of the OCP than the companies that are part of it. There's almost everyone is part of the OCP. And it's a fantastic organization. It's a forum, essentially. It's an online forum, and there are regional events once or twice a year. And then there's one global event, normally in the fall of the year in the Bay Area, in San Jose, where you actually physically, you get together all these people. And if in some cases, finally, you get to know people that you've been working for 1 or 2 years, you've never seen them in person, or old friends. But the beauty of the OCP is that it's not a commercial environment. No one is trying to sell anything. It's just a possibility to meet with like-minded people and that are very expert of their field. And you exchange experience, ideas, and opinions. And then, so there are buckets, let's say, that there are projects that they work on topics. Could be what kind of connections you use for your computer. So there's hardware projects, there's cooling projects, there's software projects. So depending on what your expertise is, you just call in these calls. They are open to everybody, and you participate. And it's a very effective way to, let's say, exchange ideas and have feedback. And then the outcome are the OCP has various products, let's say. So they actually, this common of brain trust produces a design that then is translated actually in real things. For instance, there's a rack for computers that has been designed by the OCP that is very smart and is not a chance. I mean, it's been designed by the smartest people in the industry across all the different companies. It's very effective. And or white papers, and I say, I want to know more about sustainability in data centers, and the OCP publishes 1 or 2 white papers per year talking about the latest information about this kind of things, or decarbonization, or liquid cool, whatever. There's a long list of topics that are published every year. So if you are in this business, probably about OCP already, but if you don't, I strongly encourage you to actually Google ocproject.net, I think, and you will find all the different projects, and it's a fantastic opportunity.
If our listeners also wanted to learn about what you're doing at BP, how could they learn more?
So I work for Castrol, which is owned by BP. And so I joined BP relatively recently in November of last year. And after a long career in the cooling and data center business, what convinced me to join BP is that, again, this is just public information. You can Google it, but BP is the only super major, oil and gas super major, that has decided to actually step away from oil and gas. So it's the only one that actually is decreasing the extraction of oil, and is really betting on sustainability and renewable power and green energy. And that was very appealing to me. I have kids, and I would like to leave them a world that is better than the one that I actually inherited. And one of the business that Castrol, as part of BP, is working on is the cooling of the data centers, as I mentioned before, which is a huge amount of power that is used every day. Power and water. We can talk about the water in a minute if you want. And we hope that through our technology, actually, the amount of power and the amount of water that is used is reduced dramatically. I'm not talking about 15% reduction, I'm talking about 80% reduction. So, as we said before, what are the hurdles about implementing liquid cooling? A few. Again, I don't want to try to sell something as easy, but the advantages are definitely bigger. And the advantages in terms, even financial advantages, because if you use much less power and much less water, you actually save a lot of money. And if you do the total cost of ownership over 10 years, you actually see that you actually save a lot of money. And so it just really, if you really sit down and you look at the options, you really need to have a compelling story not to consider this.
Cosimo, I want to thank you for coming on the show today and providing all this super valuable information. It's very interesting what's happening. And I always like speaking with somebody who's really on top of the technology and how it's moving. And really a lot of great insights today. I want to thank everybody for listening to another episode of Failing to Success. I'm your host, Chad Kalecki, and we'll see you next time.